All right. On to the next session, which was the update transaction encoding for the OSD. Yes. All right. So that was yours, Sage.
Yes. Yep. Um, yep. So this was originally motivated from wanting to write a different, better file store, um, and finding that it was challenging just based on the way that the transactions were structured, because you wouldn't know what objects are going to be repeatedly accessed and what was going to do without actually sort of inspecting the whole transaction and then trying to infer something from there. So that's where it started. But I think there are also wins just even for existing backends, and also in the context of some future stuff that we might do with multi-data center stuff that might help. So there are a bunch of different proposals here. The first one is to make it so that when you're writing out the transaction, you don't repeatedly specify the same collection and object over and over and over again and re-encode them over and over and over again. So there'd just be a single call that gets a handle to the object, kind of like an open. That'll encode the name once and then give you an integer ID that you'd use in subsequent operations to refer to that object. And you do that for object and for collection. And that's pretty straightforward. It just means that on the decoding side, it's going to be simpler to decode. It'll be a little bit more compact, although that's probably less of an issue. And it means that the current implementations that are doing lookups in FD cache or whatever can do fewer lookups, which will be cheaper. The other half of that trick in doing that is figuring out how to do the code transition. And there's sort of two options. One would be to sort of keep the old API and have it implicitly encode the new way, or to go through and rewrite all of the callers to transaction to use the new scheme. I think either way on the back end we have to decode using the new scheme and the old scheme, which is sort of annoying, but that's the name of the game. So that's that. Then the second piece is to also do the same thing with the buffers, so that instead of passing the buffer to an individual op, you would sort of say, I'm going to add a buffer, and you get an ID back, and then you reference that from the right or whatever else. This makes it a little bit easier for the backend to do conditional behavior based on the buffer payload, without having to go through and parse all the entries and then make a decision and then go back and then actually execute them, so you don't have to do sort of a multi-pass thing on the back end. I think it also has some benefits with improving the performance of the encoding in general, like Hamo was trying to do. So I think the main thing that I wanted to accomplish with this is with the new file store replacement, to say that if the buffer is really big, then write it to a separate file and fsync it, and then either just point the object to that file directly if it's a complete object, or try to clone it into place if it's Btrfs, or do some sort of metadata pointer thing so that we can get rid of the double write in that case. It's not worth doing anything like that for small IOs, but also double journaling for small IOs is not really an issue because they're small. But hopefully that'll help do some sort of metadata only journaling type stuff. So that's what I started with. But then we had the conversations in the last couple of weeks, and the issue of encoding of the transaction in general came up. So it might be that if we take all of the big things out of the individual ops and sort of push them off to the side like this, then the actual op part can be a fixed size blob vector or whatever. That'll be faster and easier to decode, and it's only the variable length pieces that are variable length. So that's a possibility. The other thing is that one thing I noticed when adding some of the recent pieces to transactions is that the current encoding isn't really backward compatible or forward compatible, depending on how you look at it, in that you don't know for each operation in there's no length So if you don't understand the opcode, then you can't do anything. You can't even ignore it, which was a problem with the hints that are safe to ignore, but you have to be able to parse the transaction, so it didn't actually help. Right. So those are the pieces that I originally started with. So I guess we can talk about those specifically or other options.
Yes.
Yeah. Yep.
Can you hear?
Okay. Yeah. Hey.
Okay. I think we can share a design overview PowerPoint to screen, and let
Sure.
us. Yeah.
Yep. Okay.
Yuandong will share it. Hello.
There we go.
Okay, thank you. I'll show our design point of the transaction decoding code. Follow Sage's blueprints. Can you see that? I will give about 7 pages about the details of the design. We are considering reduce the cost of induce and encode and decode of the transactions, and this is one point, and another is how much event messenger. She will talk about that part later. And for this part, we focus on the transaction interface, which is it's a class of the object store. We design 3 for the from the point of stages. We use a new transaction interface, which we will first get the object or the buffer from the transaction. Then we can do that with the index ID of the object or the buffers. So we can use the lookup instead of the encode and decode. In the transaction, we use 4 fields of the data. There are 2 hash maps, which can use to look up a collection or object from the transaction. So each object can be encoded only once into the transaction, and in the following operations.
You're good.
Can you hear?
Yep.
Yes, I'll continue. So we have the 2 hash maps to get all the collections and objects from the transaction. And for the OP is a trust star. The trust star is filled with first OP is a struct, and many derived structs for each kind of OPs, and for each OP is a fixed size struct. So we can decode from the OPs use just a pointer, not decode operations. Just a pointer to get the operation which is and what is the data. And for all data that is used for the operations, just as write or OMAP set values, we append all data in the buffer list. That's is a field named data. The ops use pointers to point data. So there are 2 rules about the data, all the fields. Collection and object index ID begin from 0 and increased for each object. That is, we just encode every object or collection once. And then buffer index ID is the offset of data for a given buffer list. So there's no encode or decode for data. That means if we get a 4K object write operations, the message will give the data, and we just use that, and we don't encode it in the transaction again. That is a key point. So we do a simple compare with the current transactions. In the primary, current transaction need encode, decode every collection objects, ops, and data's OMAP values. But for the new transactions, we just need to encode every collection object once. And for OPs, we use the package then. So there is, we can consider it a very related encode. And the data and the OMAP value is used directly from the messengers or PG layers. So there's no encoder at all. And for decode, which used by the file store to write the data to XFS system, there's no decode because we have all the struct in the memory. We can just directly use it. Don't decode it from the buffer list again.
So can you go back to the previous slide really quick?
What?
Can you go back one slide to the slide
this one?
2? Yeah, so it's the idea that you would put the ops would be packed together at the beginning, and you would put the buffers at the end,
together.
Or you would okay. So you have to know what the all of the buffers are gonna, because you don't know what the size of how many ops are gonna have and how many buffers are gonna have. Are they gonna be mixed together, or you put them?
No, it's described by each OP.
Okay.
By struct. So if
What
you
was
see
that?
the red OP, it must have the length and the offset for its own data. It's offset of this field.
I see. So you have one. So you're putting all of the data buffers into this bufferless data.
Yes.
And at the very end, you'll basically just take the number of operations and the fixed size of that struct and pack it in at the very beginning, and then the buffer data goes at the end. Okay.
Yes.
Okay. So there's one extra field basically that's like num ops, kind of, right? That would be in the transaction as you're adding these ops. And you would guess that you'd probably put that in an STL vector, and you'd reserve like 50 or something that's going to capture 90% of the users. Okay. For the one suggestion would be for the file store up thing. You can do the union of anonymous structures or whatever. That's so that you can sort of have named arguments, but still make the structure a fixed size.
Yes.
Make it easier to use. Yeah. Cool. Okay.
Okay.
That sounds good to me. Oh, sorry. One last thing. The fields. I think it seems like the hash map you don't actually need that, because it's really the caller knows when it opened to the collection what ID it got.
I know that we discussed that operations and that issue with Homai. He said there is a text that maybe the callers add the object twice or many times.
Okay. Yeah, that makes sense. Okay. Yeah, it might make sense to use an STL map there, because the hash maps I think use a lot of memory, even when they're small.
The STL map.
Yeah, and yeah, maybe, I don't know. You could profile it, but I think in the common case you're only going to have one of each.
Yes.
And so you usually won't need it. And the hash maps I think are big, even with one item.
Okay. Indeed, at the beginning we just consider use a vector and use a lookup very slowly. I think just one is okay.
Yeah. Okay. Cool.
Okay. Anything else?
No, keep going. That's it for there.
Continue. Okay. This page is a comparison with current transactions. I think we can just describe it.
Yep. Yeah, it looks great.
Shall we repeat or continue?
I think continue. I think the one thing is that the file journal using write v. I think we do that already with all the pointers that are in the buffer list. So if the encode is basically just adding a pointer to that op vector and the existing buffer list, it's like all you're doing is you're adding 2 items to the buffer list. You're not actually copying any data. Then that'll all happen automatically, right? So the buffer list write to file descriptor already uses write-v. It'll traverse the list of pointers and it'll build up a write-v vector, IOV or whatever, and write it. So I think you get that basically for free. Does that make sense?
Yeah, it makes sense.
Yeah. Okay.
Okay.
Cool. Okay.
Okay, the 4 pages. With comparisons with the current transaction for the replic is much easier because the new transaction almost need no decode. Just decode each collection or object once for each. And the ops maybe use a big buffer list copy to charge points. So we can just we can consider it as a very lightly decode.
You could also, I think you can avoid that buffer list copy if you make sure that the op structure is like 8-byte, is a multiple of 8 bytes, and all the fields are memory aligned, and you use the underscore LE 32 and 64 types.
Yes, I think
then the Indian, the Indian conversion will happen transparently, and you can just point directly into that buffer.
Which we think here is that maybe we must, if we don't use the buffer list copy, we just use the buffer list, right?
Yeah, so I think, so you just have to make sure you use those types. And then I think the one other thing is that we need something in the buffer list class that will basically say, make sure that the next, however many bytes are contiguously allocated. Which is like always basically going to be true of stuff you write over the network, but we still need to confirm because it's not. Yeah, we just basically need to assert, and if it's not, then it'll just do a copy in memory to make that free. But
I see. Yes. Okay, that's this page, and we still need encode decode because the transaction must be transferred from the primary to the replica. So we can just include the 4 fields of the transaction into 4 separate buffer lists or into 1 or not. That's not that can be depend on the MOSD sub OP. So we can use 4 buffer lists or we use 1. That's both okay. But for journal, we can just use right away. So maybe there's no encode decode here. Is that okay?
I'm not sure I understand transaction can be represented by. I mean, right now, the transaction is internally mostly a buffer list. It's not sort of decoded in the in-memory structure. When you add things to the transaction, we're just appending to the buffer list, and when we iterate over the existing buffer list, we're just iterating over the buffer. So I think none of that will change. Yeah, maybe I think so, but I'm not sure I'm understanding what your question is.
Okay.
Do you understand, Sam?
Okay. We just do some other issues. We think some core data structures must has very fast encode decode methods. So we test there are the difference between 2 methods. First is a fast encode, which we use additional memory, and we just calculate the size of structure first. Then we malloc the memory, and we use a then or a memory copy of each field. With this method, the encode of the G object text can be reduced from average 5 US to 3 US. So there is 7 cores per IO in the 4K write-4 operations. We just do the text to ensure that we may have more effective encode method. So the whole operations can be much faster, much faster, and we can have less latency. So there is a text results which we use execute CTX as a text method. We use system types to text the cost of this method.
Mm-hmm. Okay.
So, you see.
So are you changing the in-memory representation so it's the same as what it would look like when it's encoded?
Yes, it's different.
Okay. But one of the main things the encode does is it wraps it in the length of the overall structure. Right. It sort of encapsulates it.
Maybe we can consider it as a new version of the encode decode.
Yeah. Okay. Okay.
Okay, we can go well with the older.
It's the same actual encoding scheme, right? It's just the faster implementation, or did you actually change the format?
No, we didn't change the form. We just packed aside.
Just optimize code. Okay, cool. Okay, yeah, I think the other thing is that the buffer list append itself, I think, is pretty expensive right now, and I think that's something we can do. We can improve. Yeah. Okay.
Okay. We also test the whole cost for transaction, which spent by the encode and decode. We use the 4K write operations for the text switch, text case, and the PG layer spent about 80 to 100 US on encoding and no decode. The decode is not considered here. So there is total about 18 and the double of this time spent on decode and encode. We think we may reduce more than 100 US by fast or no decode encode. Okay, that's all points.
Sounds great. Have you started implementing the transaction stuff yet, or is this just a design?
No many codes, but just some idea or text.
Yeah. Okay. Yeah, I think that sounds great. I think sounds good.
Is this possible to get into Hammer? What's the feeling?
I think so.
Maybe. Can you guys hear me?
Yeah. Forever the optimist. I think it feels like that the hard part is going to be that the transaction interface is going to change into this handle-based get object, get whatever, and on the back end, the actual file store implementation, the thing that decodes it and performs the operations will have dual versions of that, one that does the old encoding and one that does the new encoding. I think that's going to be the hard part. The actual encoding itself is sort of a small matter of optimizing. Optimizing the code.
I consider that issue, and I think we can just decode the transaction of the old format and transform it into the new format, and the fluorescence is the same.
Could be, yeah. Oh, right, because you have a vector of ops, and yeah, okay, yeah. But I think the thing that would be risky for Hammer is the testing and validation to make sure that's going to be safe, right? I think that's what's going to be the risky thing. It's especially if this can sort of start in earnest soon, then hopefully we can get the pieces in early on, and that'll. If the code is finally ready in like December and we're merging at the last minute, then I think that's not going to fly because this is a big change. So sooner is definitely better. Yeah, I like the scheme. Sam, do you have any sort of comments or concerns?
It looks good. So things that will help to expedite the merging process. One, we need very good tests covering the conversion between the old and the new formats. We need to be really, really sure that's going to work right. So that's going to be that's going to take some time. So probably comes in the form of some unit tests just to check that you can convert the encodings from one to the other, and obviously tests in the we have some unit tests that test with an actual file store. Those also. Everything else can probably be done with mixed cluster tests that we already do in Tautology.
So I mean, it should be pretty easy to build up a big corpus of old encoded transactions. We have a pile of them, and we can generate a pile. I think how would we verify that the new ones are semantically equivalent?
Do you mean how to encode this field for buffer?
Actually, if they're truly semantically equivalent, then it's just a matter of doing a JSON dump. It should match, right?
Yeah.
Right,
Okay.
I mean, there's that handle concept, so we could have a new style dump as well that dumps it in terms of handles, but it's easy for the dump to do the conversion on the fly. So that's
okay.
So actually, yeah, just add a lot of transaction dumps to the object corpus, I suppose.
Okay. Huge corpus. Action dumps. JSON dump.
Covering, by the way, all of the ops and not just the ones we use often.
Yeah, I mean, you want to like stress a cluster with all of the unit tests probably, and some real recovery, and that'll probably give you a pretty
well, that'll give you the ones we use often, but we don't want to get into a situation where it turns out there's something we haven't used in a while because, for example, it hasn't happened since Cuttlefish, and that gets so
yeah.
There are only 30-something ops. It can't be that hard to generate.
Yeah.
All of them.
Yep. Okay. Maybe step 0 would be to get the whip object store stuff in too, and see if there are other. So that branch just tries to simplify the set of things that are in the object store interface. It cuts out like collection, add and remove, and some other stuff that isn't used. We should just look for anything else that isn't used, and any other opportunity to simplify. That was everything I found when I was sort of motivated. But it might help to have a fresh set of eyes. Just look for any other parts of the API that we can get rid of.
Yeah.
Did you have anything else on your list, Sam?
That's the main thing. I mean, I think this drops straight into the current interface. I think you can make this entire change in the transaction object. Later on, we'll make further changes to do the actual handle-based thing, but I think this is independent from the handle-based change, right, Sitch?
You can do it. It just means that every time you call the old methods, they'll have to do that lookup and see, do I already have a handle for this, or do I not? Which is.
I mean, you can do it in either order.
Yeah, you don't get the benefit.
They compose.
Yeah, that's true. Okay. And we'll want to.
Actually, no, you have to do this first.
Yeah. Yeah. Okay. So
well, for one thing, I don't think it works that way. I think the handle-based one is that happens to share an encoding. I don't think they share methods. That would be weird.
Yeah, I mean, the question is if you want to have both the transaction present both the old interface and the new interface at the same time. I think that's.
I'm kind of wondering, is there a good reason even to expose the handle-based concept out of the transaction interface? It can easily map. Oh, go ahead.
Because all the callers pass in the same collection and object over and over and over again, and you have to do a hash lookup and a comparison in the it's slow.
Okay,
right.
fair enough.
At this level of optimization, we want to get rid of that.
Okay, that's fine then.
Yeah. One question I had was whether the things in thinking about what goes into file store op, that fixed size structure that is small but not necessarily fixed sized. The thing that stands out is the X adders have a name, and usually they're small, but not always. I guess we might as well just point off into there's no reason not to just shove this into the buffer list and point
I think you have to, because otherwise every other op pays for that size.
Yeah. And it's the one that stands out is like the underscore attribute, which is set on every single thing. So there's going to be an extra. You could have like an inline 8 bytes, possibly, or something.
Yeah, but the value is big anyway. I don't think it buys you anything.
Yeah. Okay.
Oh, so wait, is UN16 enough for an uplink?
Yes, for that structure. It doesn't have any. This is a fixed size. Oh wait.
No, hang on. You can write more than 65K at a time.
Yeah. So I think the way I understood this file store op is actually going to be like, it's going to be 64 bytes and basically fixed size, and it's going to be a union with a bunch of named members in there. And oplen is just going to be basically 64 bytes every single time, and the only reason we would put that length in there is in case we needed more fields. Did I understand that right? Or
I thought that was the length of the entire payload. Maybe I misunderstood. How does that work?
Yeah.
Yeah, this oplen field, what is that? What's that describing?
Optimist, yeah. What's the optimist, right?
Yeah.
Yeah. But if it's a fixed size structure, is that always the same value?
Yeah. Same value.
Okay, so that's there for like future compatibility changes, basically.
For each type of the operations, we need to decode it from the OPs, the chair point, and we use the OP length. They are the common headers.
Okay.
So we need which range of the memory is which OP.
Yeah, I think that's the decision.
Okay, so I would simplify that and look at all 30 ops, and none of them have more than like 4 arguments.
Maybe the OMAP
and just make it a fixed size union. But the OMAP values are going to point into a big blob that's in the buffer list, right?
Yeah.
Yes.
So I would make this fixed size. I would still put the oplen in there, but it's always going to be the same, just so you can, when you're decoding, you can.
I got the idea. Yes.
Okay.
Oh, I see. I misunderstood. Okay, that makes sense.
Yeah, so we do the same thing for the Rados op that goes over the wire in Rados.h. There's a union with a bunch of named structs, and so you can get at all the args with names, and they're all in a union and easy to use.
Yes.
So, yeah, same thing. Okay. That's great. I think
I just think
maybe OMAP set only support one element
in map, so we can store key into file store OP and Weil can store into data buffer list.
If the key is short, you mean, and if there's only one key?
Yeah.
Or in general, yeah. I think you could do the same thing with setx adder also, because like every op is going to have a setx adder on that underscore attribute. That's 1 byte. So you could have you could have it either inline in the structure if it's short, or otherwise it'll point into the buffer if it's long. That type of thing.
Yeah. We want to totally discard the STL include decode such as map or others.
Yeah, at least for passing it around. You'll have to decode it when you're feeding it into LevelDB when you're actually doing it at the end. But
maybe we can make the transaction of the object store abstract, and each backend have their own transaction implementations. So this transaction implementation just for the file store, and maybe the key value store can have their own transaction implementation. They share the same interface. So
I think
that can't work. You might have OSDs with different backends. So the transaction format itself is an on-the-wire format, and it's used to interchange data between OSDs.
Yeah,
that's why we're encoding in the first place. Pretty much.
But I think you still have there's even if you're passing around these maps in sort of an encoded form, where it's just a blob of data that has the structure of number of entries, whatever, the same way we encode the STL list. Even if we pass that into the key value DB interface, abstract interface, instead of passing it as an STL map, but pass it as that blob, then the part that glues into whatever the actual backend key value interface is could do whatever conversion is necessary. Because I think even on LevelDB isn't taking an STL map. We have to like build up a different structure there, right?
We have to build up a transaction, but it doesn't expose any useful information about the structure of the transaction. So we're not going to be able to do anything clever in the conversion. We're going to have to decode it and then re-encode it the same way. We might as well pass it.
Right, but you could pass it as an encoded buffer and iterate across the buffer and build the LevelDB transaction instead of decoding and allocating a bunch of memory as an STL map and then iterating over the in-memory map.
Oh,
right, you could skip that. You could skip that allocation step and just walk over the. Yeah.
That's true.
Does that make sense? So we could change key value DB to take encoded. DB store or RocksDB. Yeah, I think that would be probably helpful. Yeah, because even then that would mean ideally that the OMAP calls all the way on the client would be encoded into a buffer once, and that buffer would be sent over the wire and bundled into a transaction and sent all the way down to the low-level backend store before they get. Then they would never be decoded and re-encoded, basically, right? We might have to have a validation step where we walk the encoding just to make sure it's valid. It does, in fact. Does that make sense?
Yeah. Just look at that code and see it's possible.
Sounds good to me.
All right.
Any other suggestions, Sam? Or Jeanping? Saying that right? This looks strictly better than my proposal, so I'm all for it. Cool.
All right. That cover off on everything for that one then?
Mhm.
All right, cool.